So here's our starting position. I've adjusted the lower valve and I'm going to leave that fixed. We have a steady state level in the reservoir here at the lower mark, and that is controlled by output from the upper reservoir at this lowest notch there marking. So we'll open it up and see what the new steady state level is in the lower reservoir. The upper reservoir has a fixed head here, it's overflowing. So that means that what's supplied to the valve is not fluctuating. But I will use that valve in turn to control the rate of input into the reservoir here, and then monitor the steady state level. Again, the lower valve is fixed. All I'm doing is adjusting the inflow. So let's see what happens. We're going to go for this intermediate position first. Oops. So just to show, I was at this lowest position. I'm adjusting it to that intermediate position. Hopefully you can see that. And then we're going to see what the response is here. And you can see it's already increasing. And we should get some intermediate position. Patience. So the level is increasing. Again, from past experiments, I've gotten some intermediate position. We might not necessarily get that marked position, but hopefully what's been recorded is that the response was to the increased input was a bit faster at the start, and then slows down. It asymptotically approaches the new steady state. That makes achieving steady state very difficult to determine. Requires a lot of patience because there may be a long, slow approach. So that looks pretty good, actually. Again, I might increase a little bit more. Okay, now what I'm going to do is further increase the inflow. So take it up to the highest notch, and then we'll see what the response is. Again, from previous experiments, it should be up near this upper notch. We'll see. You can see the response is relatively rapid, but then it should slow down as we approach the new steady state level. approaching it pretty rapidly. We might go over just a tad. Definitely don't want the wind to blow us off course. I think you can see that it's slowed. The rise is slowed. And yeah. So again, whether we achieve exactly that mark or not, these valves are plastic. They're quite soft. The seats are deformable. Trying to reproduce flow rates is difficult. That's done pretty well, actually. I really should leave it for about 5 minutes to see whether or not that is the steady state, the new steady state. It looks like it's just increasing a little bit, but I am not well known for my patience. Okay, now what we're going to try to do is, having hopefully at least approached the new steady state, I'm going to try to bring it back down to that lower level. So I've turned it all the way down, and we'll see. Should be dropping. You can see that. We'll see how close we get back to our original position. Somebody's having a good time. We're going to undershoot a little bit. But it slowed down quite a bit. So, yeah, I think that worked out pretty well, actually. Yeah. With our setup, and again, the key is having the upper reservoir here have a fixed height above the valve, so that it's only the valve constriction that controls the flow. That way, if my input here fluctuates a little bit, as long as that level is maintained, I'm okay. So what do you think about that, Blink? You think that works pretty well? I do. Yep. So we're back again. Just gonna check that level. And it looks pretty darn stable. So, I'm not exactly sure how long it's been, but at least 10 minutes, maybe closer to 15. So that's that lower position. Yeehaw.